Hi there, welcome back. Welcome back to another video on the Grundig Satellit 6001 series. In this video, what I want to tackle is the IF alignment for the 460 kilohertz. It sort of touches onto the first or the other intermediate frequency stage, the 1.85 megahertz. But this is primarily on the IF alignment of the 460, which is the one that's used for the AM bands. Now, this one is different and yet the same or similar to a previous one that I've done, the Satellite 2100. And the reason I'm mentioning this is that I tried to go into quite a bit of detail, but a lot of the stuff that I'm doing here, I actually saw my own videos on the 2100 to remind me. Yeah, it's not ego, it's need. You know, when you don't do these things often, you've got to sort of see what it is that you've studied before. And that's what I've done. And I realized that if you really want some help in getting through these stages, perhaps going back to the 2100 will be of great help for you on this particular radio as well. So especially on the logic of how the alignment goes. So I hope this video proves useful to you. If you think it will, stick around. Enjoy it. Before carrying on with the IF alignment, there are a couple of things I want to do first. We've got this number one here, which is using R558 to set the 7.5 milliamps idle current. Done that. Now it says here with R514, you have to set the voltage across that diode ST1 to 2 volts. All right, where is that? We're still on that main board, the one that's got the audio amp circuit in it, where I made those adjustments and put the new transistors in. And it says we have to adjust a trimmer, which is this trimmer here, R514, that one, till we get 2 volts across this diode, this 2.1 ST1. Now we've got to find that on the board itself. And if we look at the board here, here it is. And the trimmer is that guy there. Now this is a strange trimmer. This is actually right flush up against that IF can. And we've got to set it to 2 volts. They say you've got to set the supply voltage to 9 and we'll measure across that diode. So let's do that. So we're looking at this board and we've got to find that diode first. And there she is. That's that diode there. I've got the voltmeter connected across the 2 pins on the back. And the trimmer we have to adjust is that one over there. And it's a strange one because I think I'm going to have to use a set of pliers to sort of twist that. Let me move away and try and do that on camera. I have medium wave depressed. I've got no signal. And what I'm measuring at the moment is 2.25 volts, which is pretty close. But I need to try and adjust that. And as I said, it's a little bit tricky. I need to sort of get this little plier in there. Oh, it's working. That's good enough for me, 2 volts. That one is done. So number 2 is done. Number 3 says the emitter current of transistor T14 is adjusted with R509, which is a trimmer. And you adjust it so that you measure a voltage across R512 of 1.5 volts. So let's go and see where that is. Here we have transistor T14 over here. And you have to set this, oh, here it is, set this voltage across this resistor to 1.5 volts using that trimmer. Is that right? Yep, that's right. What this does is it sets a bias across here, through these coils to the base of the transistor. And of course, whatever voltage you set at the base will affect the voltage across here, and whatever voltage you have here will affect the current you have through the resistor. So we need to set this to 1.5 volts. I've got to find resistor 512 and I've got to find trimmer 509. Okay, here's resistor 512 over here from the emitter to, what is it, to 0 volts. Okay. And then we have to adjust 509, which is that guy over there. So let's find it and do it. 1.5 volts. I've got that the positive of the probe on that resistor 512. The negative goes to 0 volts. At the moment I've got 1.65 and I want to adjust this guy to 1.5. Wrong way. It's a little bit high. This thing is very stiff. That'll do it. It's climbing up slightly. It'll go to 1.5. So that one's done as well. Good. So number 3 is done. And now it says set the supply voltage to 7.2 volts. And with a voltage of 7.2 volts and with trimmer R564, you have to set the battery monitor, in other words, the battery level indicator, to the top, the line between the red and the gray, and you adjust it. Okay, I think that's just to calibrate the voltage, the battery tester or the battery indicator. Let's find out where they are. Well, here's our 564, and the voltage indicator obviously is on the front, so this one should be quite easy. Now this one is such that you can actually get the screwdriver in through the back. There's a hole on the back there. So I've got that ready, and I'll look at the indicator and we'll take it from there. Obviously the power supply is set to 7.2 volts. Okay, now to see the battery indicator, you've got to pull this up, and if you can see that, it's going all the way to the top there. So I'm going to get ready. This is a bit tough to do, but I'm going to give it a try. Something is shorting at the back there. Okay, let's try again. Nearly there. As I touch it, I'm obviously messing with this thing's a bit bent. Okay, that's better. It's a bit high. The trim part was actually bent back a little bit. Okay, I'm looking it straight on. It's perfect. It's on the top of that bar. That should do it. So now we've done that guy. All this has been set, and we've got to carry on. And if we look at this instruction set, what it tells us to do now is, well, it tells us that we've got to do the IF alignment for the FM, which I'm not doing yet because I haven't got to the FM. So we'll skip that one. And we come down here to the FM alignment or the IF alignment for the AM, and there are two. There's the 460 kilohertz, and then there is the 1.85 megahertz. This has got a dual conversion, dual IF. So what it means is that this particular IF is used on the upper shortwave bands, so shortwave 2 to 9. These are only on, or rather, the lower bands, so shortwave 1, medium wave and long wave, only use the 460 kilohertz. And here they start telling us to play around with different filters, and we can see that they tell us various things. First of all, you've got to put that on narrow. So you've got to set the bandwidth select to narrow, so you're going to make it as sharp as possible. And what do they tell us to do? Well, they go to IF filter 9, and they tell us where to inject the signal. So this means where do we inject the signal? And it says on point 4 of filter 8. So you're adjusting 9 and you go to point 4 of filter 8. And it says loose coupled to collector of T15. Loosely coupled to collector of T15. I'll explain in a second what I do there. And then it says you adjust 1 for maximum. And we go then to filter 8. Remember, we were at filter 9 there. Then you inject it at point 4 of filter 7. See the logic? You're going back and you adjust 2 for maximum. And then filter 7, injected filter 6, and you go 3 and 4 for maximum. So what exactly are we doing here? Well, it actually makes sense when we look at the whole thing. This is really what we are looking at. We are looking at 1, 2, 3, 4 filters up here. Then there's another one there and another one there. But the first stage they tell us to look at is this one here, filter 9, if you recall. And they tell us to detect at the collector of transistor T15. And it's loosely coupled. In other words, you don't actually put the oscilloscope probe or the detection probe on there. You have to loosely couple it. And I'll show you how I do that. But that's where you detect. And the first one you adjust is this one here, which is that guy over there, which is on filter 9. Then at that point, they tell you to inject at point 4 of filter 8. So you inject the signal in here, you detect it, you read it off there, and you adjust this for a maximum deflection. We'll explain what the deflection is in a minute. Then they tell you to go back, and you still measure everything here, but instead of injecting here, you now have to inject there. And you adjust that guy till your deflection is a maximum. So what you've done here really is you've opened the sluice gate. You've really opened that gate for the IF frequency, because the signal that you want to get through is the 460 kilohertz IF signal. It's an IF signal carrier. It's a carrier with the audio information modulated, amplitude modulated on it. All right? So that's what you want to get through. You want nothing else to get through, or as little of anything else to get through as possible, but you want that to get through clearly. So that's what you do. You're sending a signal in, and I'll show you where we put the signal in a second, because at this stage they're telling you to put it in here. Measure it there and adjust that one. And why? Because this is actually a load to this transistor, but that's besides the point. The point is you open that sluice gate till the 460 is getting through, the one that you're injecting just before it, all right? And then they say, right, now you've cleared that path to be able to see it there. Let's go one step back, because we've got another gate here, another sluice gate. And you take the signal from here and you put it here. And now you're measuring at that point and you open this tap. You adjust this gate, this sluice gate, till you get this signal coming through at a maximum at that point. So now you've opened that one and that one. Then they tell us, go back further, inject it over here. And now, still measuring at that point, you adjust these two sluice gates to tune them to 460 kilohertz, so that that signal gets through this one, through that one, through that one, as optimized as possible, so that you can read the highest deflection on there. And that's where we really are interested in. But there's one more, because now they tell us we need to go back one step further. And at this point is where you start playing with that, the second IF. In other words, the IF that comes from the shortwave 2 to 9. But what we can do is we can actually adjust, we can actually inject. When they tell us to inject, they tell us to inject it over here. But in order to do these guys, all these guys, instead of injecting there, injecting there, injecting there, what I'm going to do is I know that some of that is getting through because I'm hearing AM radio. I am hearing it. So it's not hidden. It hasn't disappeared. I can hear it. So if I inject in here, right, that means I can adjust all these together for a peak, as opposed to going it, one step at a time. So that's what I'm going to do. I'm going to inject somewhere around here. In fact, it's easier to get to this point by injecting here, because I can see that is a cable coming to that board. These points are a little bit difficult to see on the underside of the board, but that cable, that connection, I can see. So I'm going to inject in here. The signal is going to get through. I'm not going to adjust that one yet. I'm just going to adjust those two, that one, and that one. But what exactly are we trying to do here? Well, it actually makes sense if you look at it in a sort of, graphic way. Imagine that you have a signal, a carrier at 460 kilohertz, a sine wave, right? But on it is audio information superimposed. So you have an AM modulated carrier. That is the basis of AM radio, AM transmission, AM reception. Now this is the IF frequency, 460 kilohertz. And imagine that it's coming into a part of your radio as 460, so it's gone through your IF. It's at 460. And now it meets a filter. Now that filter is like a bell curve. It's a cutoff filter. It's got a pass band which is sort of fairly narrow, all right? But imagine that filter is not quite tuned to 460 kilohertz. Imagine Imagine that it's tuned to about 450 or 455. So it's somewhere down here. This is the peak of it. Now what happens? This 460 kilohertz signal is trying to get through, but it's met a filter that doesn't let it get through completely. It attenuates it. You see that? So you're basically cutting off a lot of the power of this signal that's trying to get through. And that's not good, because you want it to get through. You wanted to cut everything else, but you want this to get through, because it gets worse. There are 4 or 5 of these filters. Now imagine the other one is on this side. Well, that's just made it worse, isn't it? Because it's cut off. It's been cut off by both of these filters. And just to make it worse, you got another one, and it cuts off some more, and another one, and it cuts off some more. So before you know it, your signal is being chopped to bits. So you need to sort it out. You need to adjust this so that all these filters align on 460 kilohertz to allow that 460 kilohertz to get through. So you've got to move these guys in line like that. You need to take each one of them. You need to make sure that they are aligned like that. And once you have all of them aligned, that's your magic point where this signal gets through as strong as possible. And that's what you want to do. In this particular radio, we want the strongest peak. So that's what you want to do. There is something called stagger tuning, where you take that one to the left and that one, or that one to the left and another one to the right. If I can grab them, I can't. Something like that. You can do that, and you stagger tune them so that the band pass, or the bandwidth of the signal, can be greater. But that's not what we want here. We actually do want to align them so they are optimum. Now, so why am I not worried about doing them one step at a time? Well, because I can hear something. You know, these things might be as misaligned as they want to be. I don't know where these are, but I can hear that. So if I make any adjustment to any one of them, any filter, I can improve the reception. I can hear the result of improved reception as I move it closer. You see that? That shade, it's allowing some through, right? And all I need to do is to optimize it like that. Well, close enough to make sure that it gets through as best as possible. If I couldn't hear anything, if this thing was completely silent, then I would have to go one filter at a time, starting at the end and going backwards. But I don't need to do that because I can hear it as it is. All right, that's what we're going to do. Okay, let's get started. I have to lightly couple the signal out of the collector of that transistor 15. So what I've done is I've soldered a yellow wire to the collector, and this orange wire is just wound around it. There's no electrical contact between them. It's basically acting like a small capacitor, and I've got the scope probe at the end of that. That's where I'm reading off the result of the 460 kilohertz signal that's going through the entire, or practically the entire, IF chain, and we'll see that on the scope in a minute. Now the input of the signal is going to go into that point over there. That's where it comes into the IF circuit, as I showed on the schematic. I might have to solder it if it doesn't. Oh, it's going to hold, I think. It's holding. So that's going into the beginning of filter 6, all right? And now we're going to start aligning this. But first of all, I've got to send a signal from the signal generator. And what I have is 460 kilohertz coming in, the lowest amplitude I can. It's going into the switch attenuator. There's, what is that, 30 dB attenuation. So I need a very small signal that's going to go into that IF circuit over there. And I've got the scope connected. So I'm going to switch everything on. I'm going to switch the radio on. And I'm going to switch the signal generator on. And it slipped out. That's not good. Okay. Put the volume down. We don't need to hear it. And we're ready to start. So we are looking at the scope, we're looking for maximum amplitude, and we start on this one here. That's adjustment point 1. No, other way around. There's a peak. That is a peak. Then we go to this one. That looks like a peak as well. Now this one. Wrong way. That is a peak. And this one still has wax in it. That sure looks like a peak, doesn't it? Yeah. And finally, this guy. Let me change the scope. Get it down there. So we've peaked those coils. That one, and that one, that one, and that one. And we've done it. Now we're going to go back to the instructions and see what else they tell us to do. Now, just a reminder, on the Satellite 2100, which is very similar to this in terms of alignment, the instructions for alignment are very, very similar to this one. I've gone into it in great, great detail. If you really want to see the detail of how it's done, go and check out those videos. I'll link it above. Okay, one more step completed. If we look at this drawing, you'll see which ones I've done. I did this one, that's 1. This one, which is 2. This one, which is 3. That one is 4. And I actually did that one, although I think to do this one correctly, you've got to inject the signal somewhere else. We'll see what the instructions tell us, and that's 5. So here we are. We've got 1 done, 2, 3, and 4. We've actually done 5. And you see with 5 and 6, they actually tell us to inject it somewhere else. They tell us to inject it at the base of T8, okay? Whereas I actually injected at the initial stage of that filter. So I'll have to just adjust that when I do this, this alignment. I've got to put it on the base of T8. Loss, I think, means a loose coupled. So I'll have to see how to do that. If we look at this thing, we look for the base of T8, and T8 is over here. It's coming from where the, yeah, we can see that. You see that there? Those are the 3 pre-selectors before the mixer. This is the mixer. So they're asking us to inject the signal to the base of T8. That's the base of that mixer transistor, which is this one here. And what we can do is actually go back one step. Yeah, I think we're safe to couple it into here, which is that combined output from those 3 tunable coils that we looked at, where this one is buggered. So that's an easy access point. That should work. And the signal will go through there. It's going to go straight through because it's at the IF frequency. And we have to tune this guy here. And also that guy there, which I tuned a little early. I was injecting it into here. It shouldn't be a problem, but I'll tune that one and that one. So 460 in here, tune that one and that one for a maximum. Now, where are these guys? Well, they're not on the same board as that one. And I've got to admit, it took me a while to find it. I was being stupid because there's that those 3 tunable coils. And this is T8. It's on there. And we can, the base of T8 is actually quite easily accessible. As I said, we can use that connector there, which is the output from those 3. It goes through a resistor to the base of T8. And then the coil we have to adjust is down here, just below it, which I think is visible from the back. So let me set that up and see what we get. Okay, we've got the signal coming in here. That's that point that goes to that resistor and then the base of T8. I can just see the coil in there. I'll adjust it sort of sideways. There's actually a gap here that if you have a long one, you can get in there, but I think I can get in with this. Switch on the radio, and we can see it. You can also sort of hear the crackle, but we don't need to. So let me try. Well, that is a peak. That's all there is to that. So that one is done. Great stuff. Let's see what else we have to do. I've coupled it there. I coupled it directly to a resistor before that, so I think that sort of counts as loosely coupled. Medium wave was selected, and I've tuned these filters, so I've done... Oh, I forgot to do 6. I'll just go back and check that it's okay. I'll do 6. And then what they tell us to do is with langere Messstift IM. What does that mean? We need to adjust filter 3, and filter 3 is actually on that IF board on the base of T5, and we adjust 7 for maximum. Now T5 and 7 we're looking for. This makes sense. It's 7 is that one there. T5 is that one there. There's the base of T5. And this thing is in that second mixer, I believe. On the Satellite 2100, I had a bit of a confusion here. I ended up having to inject the second IF, 2 megahertz rather than 460. I think this might be the case here as well. I'll see. But I've got to find that transistor and that point there, so T5. Now I must admit this thing took me a little while to find. Trying to figure out where this T5 was. I kept looking on these boards. It's actually inside a metal can right on the right hand side if you look at it from the front, behind the on-off switch. And these adjustment points are sticking out of the can, so there's holes there. And 7 is this one over here. The next problem was where to inject it. And I remembered there was something here. It says on the base of T5, langere Messstift am KW Mischer. So what this means is the longer test lead or long test lead or test point on the medium wave mixer. And I didn't know where that was. So I went looking and I think I found it. I believe I have it in the right spot. There's actually a point like a pin sticking out there. You can't really see it from here, but if you look down there, there's a pin sticking out. I've stuck it in there. I've got this thing at 460, and let's see what we get. Now I'm going to switch it on, and it's there. And according to that drawing, number 7 is one on the side here, which is the lowest right bottom. Okay. It was pretty spot on. So it's staying right there. So I think that's another step completed. Well, folks, now I need to redo everything. Not that I've made a mistake, it's just that I did everything with the camera on and filming and all that. So what I'm going to do is I'm just going to go through it again very carefully, recheck all these alignment points, and make sure that they're as optimized as possible. It's not worth filming it because it's basically doing the same thing. But when you're doing it with the camera on, you sometimes can't get it as precise as you'd like. And so what I'll be doing is just basically checking all the work that I've done now for this IF alignment for the AM, for the 460 kilohertz. And this thing's going on with too many screen captures and everything else. So I'm going to stop for now. And I hope you've enjoyed that. I hope you've learned something. And don't forget, if you really want some more information on this step, on this stage, look at the video that I linked previously on the Satellite 2100, where I do go into a lot more detail. Yeah, exhaustively. And you might have noticed I took that front panel out when I was looking for that board with the shortwave mixer on it. It's kind of weird when you start searching a radio for a PC board. but I found it. It's that box there, as I mentioned. So I took that out, so I'm ready to be able to clean the drum tuner, which I'm really anxious to get onto as soon as possible. And yeah, a lot to do still. So I hope you've learned something. Hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Thanks for watching. Bye for now, and stay safe.